Hey, how's it going everybody? And welcome back to Michael Workspace. I am Michael, and in today's lesson, we'll be going over a LeetCode problem 412, called FizzBuzz. Now, FizzBuzz, you guys have probably heard about it, is a very common interview questions that are given to candidates as the first questions, just to see if the candidates can actually solve it. And if it's really meant to rule out 99% of the candidates who apply for a programming job who can't seem to solve a simple programming problem. So that's probably going to be one of the questions you get asked at the very first interview. And if you pass that, then then it might give you harder and harder programming problems. But if you can't pass the first one, then your chances of getting hired is slim to none, or they might even stop the interview after that point. All right, so FizzBuzz is a little history lesson. Is a children's game where kids play together, and is really meant to help them teach them divisions. And the way it works is that each kid would read off a number and going up by one, and when they hit a number that is divisible by three, then they will say fizz. And when they hit a number that is divisible by five, they say buzz. And when you hit a number that is divisible by both three and five, you say FizzBuzz. And you go on until, I guess somebody messed up and that person loses, and then they start over again. So an example would be 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, 12, 13, 14, FizzBuzz, 16, and so on and so forth. I can't believe I got that in the first try. All right, so let's take a look at this problem statement here, and then we'll go through coding up this solutions. I'll probably code up a couple of solutions here. One would be more like a naive approach, where it's something that a beginner level programmer would do, but then I'll try to clean up the code a little bit. I might not be able to improve on the time or space complexity, but you can write a better solution where it's more maintainable in the future. All right, so let's read through the problem first. Write a program that outputs the string representation of numbers from 1 to n, but for multiple of 3s, it should output fizz instead of the number, and for multiple of 5, output buzz. For a number which are multiple of both 3 and 5, output FizzBuzz. And they give us an example here. N is equal to 15, and then the return value is a list containing the string representation of the elements inside. All right, and yep. So again, here is a solution. Since we are returning a list of strings, let's go ahead and initialize a list here. I'll just call it ans, short for answer, an empty list, and then we'll go ahead and loop through from. It says start from 1 to n. So we go through and create a loop here for I in range 1 to n plus 1. If I mod 3 is equal to 0, I'm just going to replace I call it number. So if num mod 3 equals 0, then we'll go ahead and append the word fizz to this. Now, again, you probably end up doing something like if a bunch of if else a conditional check, which is kind of clunky, but we'll go through that as a first example. So next, if num mod 5 is equal to 0, then answer that, append the word buzz. And then now here's where we would normally check to see if you want to check to see if the number is divisible by both 3 and 5. However, this is not where you want to put it, because it will never ever reach this condition, because it goes down these condition by order, and when it will always hit 3, check 3 first, and then if it doesn't work, if the number is not divisible by 3, then it checks to see if it is divisible by 5. So as you can see, if we were trying to check both 3 and 5, it would never ever get to that point to output FizzBuzz. So where you want to do that is actually in the beginning. Check to see if the number is divisible by both 3 and 5, and if it doesn't fail, if it's not, then go down to the next condition, which is check to see if it's just divisible by 3, and so on and so forth. So I'm going to go ahead and replace this condition here. So if n mod 3 and num mod 5 equals 0, then we want to append FizzBuzz. And now here I'll go ahead and change this up to be 3, this to be fizz, and else if num mod 5 is equal to 0, then append it to the list for the word buzz. Then finally, if it's not divisible by 3 and 5, then we want to append the string representation of num. So like that. At the very end, we'll return answer, which is that list. All right, let's go ahead and run this code and see if it works. Okay, so it looks like it works. And then yeah, we can add some more test cases here. So instead of 1, 15, 100, even 1,000, we'll probably end up getting the right answer here. Yep, so that's our work. Okay, so that's the first problem, and it's okay, but as you can see, all this checks if, else if, else if, else. It looks kind of clunky, and to me it looks like a mess. And what if you were to add in another condition where if the number is divisible by 7, and then append a different word like jazz, then you're gonna go in here and do add in a few more else if clauses, and it's gonna become a hot mess. So let's find out a different way of doing this. I'm just gonna go ahead and comment out everything. So we'll still need a list. So there we go. And how can we do this? My second way of doing this is actually, since we are already appending strings to the list itself, we can actually just create a variable that is a empty string, and then check to see if the num is divisible by 3 or 5, and then just do a string concatenation for both 3 and 5 to get FizzBuzz. And if it's not, then it will just do fizz or buzz. Here, I'll show you what I mean. So for num in range 1 to n plus 1, again, that doesn't change, but for here, let's just do an answer string. We initialize an empty string variable, and then we'll create a couple of variables to store our conditional check for fizz and buzz. So fizz is equal to num mod 3 0. Buzz is equal to num mod 5 equals to 0. That way we don't need to do like in our if else if clause up at the top here. We don't need to include that logic in there. We could just say fizz and buzz in the if statement. So it's cleaner that way. So like for example, now all we have to do is just say if fizz. If that is true, then answer that concatenate the word fizz, and then down here, if buzz, answer string concatenate buzz. Now this right here, this to if, that's all you need to do to get the FizzBuzz logic into this string variable here, because now instead of doing if num mod 3 equals 0 and num mod 5 equals 0, append FizzBuzz, and then do the check for mod 3, then check for mod 5. Because we're doing string concatenation, when this first check to see if the number is divisible by 3, which if it is, then the answer string is gonna contain the word fizz, and it's gonna keep that. And then when it does the next check to see if the number contains is divisible by 5, and if so, then it's gonna concatenate the word buzz to the already string of fizz that's inside of the answer string. So that way, that's how this logic works. It looks, it's just cleaner. And then now all we have to do is check to see if answer string is empty. So if it's not divisible by 3 or 5, then it is empty at this point. Then we'll just have to make the answer string as the string representation of num itself. All right, so you can do it like that. Another way that you can do this is say if not answer string, which does the same thing. And I'll just move this to one line as well to keep it in line with the other if clause. And then at the very end, we'll just do an append answer string to our list. So, and then finally, we'll return answer. All right, so that should be everything. Let's go ahead and run this code, see if it works. And yeah, it got accepted. All right, and let me just go ahead and explain the time space complexity of this algorithm to you for both. All right, so both of this algorithm is gonna be the time is gonna be O of n, a linear time, and you can see that clearly because you're doing a for loop in both of this algorithm. You're doing a loop from 1 to whatever n is, and when you do that, it's linear time. And then it's also gonna be, both of these algorithms is gonna use up linear space, so O of n space as well, because we had to initialize a new empty array and then and add to it what the elements up to n length of our inputs. So yep, O of n time, O of n space, and there you go. Let's go ahead and submit our code here to LeetCode and see what we got. So our runtime is 56 milliseconds, faster than 12.60. I guess it's not that fast, but it works. So faster than 12.64% of Python 3 online submissions. And then the memory usage is 15 megabytes, less than 6.3% of Python 3 online submissions. So yeah. All right, that's it for today's video. If you guys like what you guys see, please help my channel out by giving a like. And if you haven't already subscribed to my channel, please do, if you do like to see more of this sort of content. All right, well, I'll catch you guys later. Have a good one.